deadline, raising a child, or having emotional or physical pain. When you don't have enough sleep, the next day you'll feel cranky and out of sorts. However, sleep deprivation is more than making you feel grumpy and groggy. The long-term effects of sleep deprivation are real. It drains your mental ability and puts you at risk of thirst. Fortunately, we can compensate and have some time to recover during sleep. Others are not as fortunate, especially people with sleep apnea who wakes up several times during their sleep. Sometimes they're not even aware of it, as their upper airways muscles collapses and obstruct their airflow. And then the brain senses that inability to breathe and sends a signal to arouse the person to reopen the airway. There are serious complications of sleep apnea. We're talking about car accidents, loss of productivity, mood swings, and there's strong evidence associating sleep apnea with cardiovascular diseases, as people with this condition have threefold higher risk of having cardiovascular diseases. The first-line treatment is CPAP, or it's cumbersome treatment, and people are showing poor compliance, so we need a better intervention. The autonomic nervous system and its branches, the sympathetic and parasympathetic, has gained a lot of attention as it controls almost every organ and function in our body. It also showed great success as a therapeutic target in treating diseases like arrhythmia, but still in some cases it showed adverse effects. This could be due to the unspecificity of the treatment, as we still do not know the exact map of the nerves in the brain of our heart. In my PhD, I'll be addressing these shortcomings, as I will elaborate using advanced imaging techniques in combination with immunohistochemistry, markers to label the sympathetic and parasympathetic nerve fibers. I will tracing those nerves and integrating them into a 3D heart scaffold to provide a comprehensive map of the nerves in the brain of the heart, and then exposing them in the mice to intermittent hypoxia, which is the most common model of sleep apnea, to see how this condition remodels that map. So far, the results show big bundles of sympathetic nerve fibers entering the heart and branching out into individual fibers covering the entire structure. And also in a certain region in the heart that controls the heart rate, the density of the nerve fibers increased after exposing the mice to intermittent hypoxia. I'm still having difficulty in labeling and tracing the parasympathetic because the pattern is different and the nerves are more delicate and faint, but I'm hoping that optimize the techniques to complete the map and contribute to the brain-heart atlas and provide a more guided therapeutic target to improve the specificity and the effectiveness of the treatment for people with sleep apnea and hopefully eventually other diseases. Thank you.